So we have spent a lot of time in the trig realm talking about right triangle trig. And today in section 9.2, we're going to be talking about solving triangles that are not right triangles. So in 9.1, we reviewed what we've learned in geometry about solving a right triangle, finding all the missing sides and angles, but it was for a right triangle. So now we're going to talk about non-right triangles. And in a non-right triangle, we have to know one side length and two other measures. So have to have at least one side, and it could be these ways that we learn to prove triangles congruent in geometry, but we can also use what was illegal in geometry, the side-side angle, in some cases as well. Law of sines is going to be focused in on just these three. So in section 9.3, we're going to do law of cosines, which is going to pick up the side, 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 and side angle side. So the reason I bring this up is because when you're given the measures, you have to look at, okay, do I have angle, angle, side? Do I have side, side, side? So you know which formula to choose. So in the case of side-side angle, which is known as the ambiguous case, we don't necessarily have just one unique triangle. We could have the possibility that two triangles could form with the given information, or that it might be impossible to form a triangle at all, so no triangle. The reason that happens is because there can be two angles between 0 and 180 degrees that have the same sine value. So when we have it in the side-side angle order, we aren't necessarily locked into one. So I'm going to show you an example of those. So when it says solve the triangle if possible, I suggest drawing a picture. It does not have to be to scale. So when you're labeling things, it may not look like what the angle measure says, and that's okay. So here, the given angle is 125, so I'll at least try to make it look like an obtuse angle. So let's say I draw this guy, and so if this is angle C at 125 degrees, I know that side C has to be across from that. Then it doesn't matter which one I make A and which one I make B. So let's just say that I'm going to do A, B, C this way. So that means side A would be over here. So when I use the law of sines, we don't actually use all three pieces together. We just choose two of the three. It depends on which angles and sides we're given. In this case, because we have side A and side C, then I have to use angle A and angle C. So I set this up, sine of angle A over side A equals sine of angle C over side C. And when I use law of sines, I cross multiply to solve. So 3 times the sine of A is going to equal 8 times the sine of 125 degrees. So obviously I'm going to need a calculator here. Important that we remember that it's in the right mode, so check to make sure yours is in degree mode first. And so obviously I'm going to be doing this over here. So mode, degree, and then I do 8 times the sine of 125 degrees, and I divide that result by 3. So I get sine of A is equal to 2.1844. I'm just writing down a value here. I know that to solve for A, I would need to then do inverse sine. So, second sine, second answer, because I'm doing the whole thing, not the rounded version. And it tells me error domain, which, if we stop to think about it, would make sense because we know that sine oscillates between -1 and 1, and this was bigger than 1. So it's outside the domain. There's not going to be, an A angle value that is going to be able to have that as its sign. So since this is not possible, that means that this was a case where there's no triangle. So again, no triangle is only going to happen if it is a special case of the side-side angle, right? Again, that's not the same as having side angle side. If the angle were between the two sides, we would have to get a solution. But this is side-side angle, so it is possible to have no triangle that will form. It just means we can't possibly connect the sides and angles in that way and actually get the triangle to close. All right, so let's look at B. So this was a side-side angle. B, I've got two angles, so I know it's definitely not a side-side angle. So let's say A is 85 degrees. So we'll make this A, we'll make this B, we'll make this C. Again, they don't have to be drawn to scale. So 85, 41.3. And then side A would be the one over here, 57.5. So if I look at the way it's set up, this is angle side, which is one of the ones where I use law of sines. So angle side, obviously I have to use A and B this time. I used A and C over here. So I'm going to set up this part of it. So sine of 85 degrees over 57.5 equals sine of 41.3 degrees over side B. So I know this is side B and this is side C. So just like we talked about before, I'm going to cross multiply. So B times the sine of 85 degrees equals 57.5 times the sine of 41.3 degrees. And then I'm going to get out my calculator. So 57.5 times the sine of 41.3 degrees gives me this guy. And I'm going to divide on both sides by the sine of 85 degrees. So divided by sine of 85 degrees. And so that gives me B equals, I guess I should put an approximate value. Remember that generally, unless they tell us otherwise, we're going to round side lengths to 2 decimal places and angles to 1. So the 5 bumps that up, so we'd be at 38.10 for side B. Now, when we did right triangles, we said don't use anything that you calculated yourself. We kind of have to throw that out the window when we have non-right triangles. We're going to have to use things that we calculated ourselves. Also, public service announcement, please don't try to use the Pythagorean theorem. These are not right triangles. The Pythagorean theorem does not apply. So do not try to use it. It cannot be used. What I can use is the fact that all 3 angles of a triangle still have to add up to 180 degrees. So up here, I can find angle C by doing 180 minus the sum of the 2 that I know. So 85, oops, not 5, 85 plus 41.3, and then subtract that result from 180, and I get 53.7. So 53.7 degrees is angle C. I don't need an approximation on that because it came out evenly based on what I was given. So then the very last thing that I need to find is side C. So I'm going to set it up just like I did when I found B. I'm going to do sine of A over A equals sine of C over C. So sine of 85 degrees over 57.5 equals sine of 53.7 degrees over side C. Cross multiply here, and then pretty much solve the exact same way that I did when I solved for B. So all I'm doing is swapping out that angle, and let's see, actually going to pull that value down because that'll be less typing for me. So 57.5 times sine of 53.7, and then divide that result by the sine of 85 degrees, and I get 46.52 when I round it to the nearest hundredth. So side C is going to be 46.52. And then, of course, there's always a lot of work, so make sure that you've made where your answers are very clear, like I did here. Okay, last one for this example. So I've got angle A, side B. So when I draw this guy, let's see, angle A is pretty small, and side B is a lot longer than side A. So let's maybe draw a little like this. Here's A. We're going to make this 29.7 degrees. Side A is 27.2 in length. I'm going to make this B and this C. B is 41.5. Again, remember, it's not necessarily drawn to scale, so you can't really use, what it looks like for your solutions. So in this case, I have side angle. So the reason it's important that I decide which one I have is because I have to be on the lookout for the ambiguous case or no triangles. So side angle, I have to be on the lookout. So set it up as normal. So sine of A over A, so sine 29.7 degrees over 27.2 equals the sine of angle B over 41.5. So cross multiply, 27.2 times the sine of B equals 41.5 times the sine of 29.7. We're going to divide by 27.2 on both sides. So, bring out my calculator. So, 41.5 times the sine of 29.7. And then dividing that result by 27.2. Which gives me approximately 0.7559. And I know I'm looking for the angle, so I need to do inverse sine of that value. It is between -1 and 1, so I should get an answer. Excuse me, inverse sine, second answer, don't round it. So that gives me angle B as approximately 49.1 degrees. Okay, so here is where we have to be on the lookout for the ambiguous case. So if you get an answer, now in A with the side angle, we got not possible, we got an error. So I don't obviously need to do it when that happens. But if I get an answer for the angle that I solved for first, what I need to do next is I need to subtract that value that I just got for the angle from 180 degrees. So you can see I did that in the calculator, 180 minus the answer that I got, because if there's a second triangle, that's going to be what I'm going to call the B2 value. So 130.9 degrees. Now, once you do that, it's always 180 minus the first angle. So in this case, 180 minus B1. But you have to check, can you still have a triangle? So 130.9 plus 29.7 leaves a little less than 20 degrees remaining in the triangle. So it is possible. So that's what we're checking. If you get a B2 where it's not going to make a triangle, then that means that there's only one. And you continue just with the original value that you got. So, again, to summarize, on side-side angle, when you get the first angle, you have to do 180 minus that angle to get the second option. If that second option would not make the triangle have over 180 degrees, then you actually have to solve both. There's two possible triangles. So, these are angle B1 and angle B2 for two separate possible triangles. So, obviously my next step would be to find angle C1 and angle C2. So, since I had already added the 29.7 to this guy, I'm actually going to find C2 first. So I added those, and then I subtract that from 180. That gives me 19.4 degrees for C2. And then I do the same thing for C1. So I take B1, which is 49.1, add it to angle A, so 29.7 plus that guy, and then subtract from 180 degrees. So that gives us 101.2 degrees. Then the last missing piece of the puzzle would be side C. So I have to set up two separate laws of sines to find it. So sine of 29.7 over 27.2 equals sine of this angle C, 101.2, over side C. And then just the same as I always do. So I've got C times the sine of 29.7 equals 27.2 times the sine of 101.2. And then, of course, I'm going to divide in order to find side C. So I'm going to do all that in my calculator. So 27.2 times the sine of 101.2. And then divide that result by the sine of 29.7. And that gives me 53.85. Can't really see it on the video there. There you go. 53.85 when I round to the nearest hundredth. So side C1 is approximately 53.85. So this is triangle 1. Then I need to complete triangle 2 in the same way, except of course that instead of the 101.2, I'm using the 19.4. So pretty much I can just copy this part. So C2 is going to equal 27.2 times the sine of 19.4 degrees divided by the sine of 29.7 degrees. So 27.2 sine 19.4 and divide by the sine of 29.7, and I get 18.24 when I round it up. So C2, 18.24. So this is what happens when there are two possible triangles. This is why in geometry, they said, oh, you can't use side-side angle. It spells a bad word backward, because you can't prove that the triangles are congruent. There might be more than one triangle. There might be no triangle at all. So that's why this wasn't a way to prove triangles congruent in geometry. All right, last one. 2 fire lookout stations are 10 miles apart, with Station B directly east of A. Both stations spot a fire. A at a bearing of north 25 degrees east, and B at a bearing of north 56 degrees west. How far is the fire from each station? So again, the key with these is drawing a good picture. So if I am going to make Station A and Station B, I am given that they are 10 miles apart. So this is 10 miles. It says that the fire, let's see, is spotted from A is a bearing of north 25 degrees east. So heading north, turning 25 degrees to the east. So we're going to make this guy fire. So this is 25 degrees. Then the Station B sees it at a bearing of north 56 degrees west. How far is the fire from each station? So that means I'm looking for these two sides. So side A, if you will, side B, if you will. Although it probably makes more sense to label them the other way, or maybe use X and Y since we're talking about how far they are from the station instead of using the across. Regardless, either way, we got to find those two missing sides. So we'll call them X and Y. If this is 25 degrees, then I can use the fact that this has to be a right angle to say that this guy is 65. Likewise, if this is 56, then this has to be 34. That also means that inside this triangle, because it has to add to 180 degrees, I've already got a sum of 99 when I add these two together. So that means there's 81 degrees left to be at angle F. So I now have one side and I have all three angles, so I can set up and solve however I want. So if I want to find X, I can do sine of 81 degrees over 10 equals sine of 34 degrees over X, and then do just like I did in all the other problems. So X times the sine of 81 equals 10 times the sine of 34. And then we will, of course, divide by the sine of 81. And X represents how far the fire is from station A. So that's the label I'll put on it once I actually solve. So 10 times the sine of 34. Divide that result by the sine of 81. And it does not say what to round to, so we'll do two decimal places. So again, X was how far it was from station A. So 5.66 miles is what we'll say. And then I just have to do the same thing to find Y for station B. So I can do sine of 81 degrees over 10 equals sine of 65 degrees over Y, and cross multiply there. So Y times the sine of 81, 10 sine of 65, and And then just like when we did to find x, I'm going to plug in the same thing. I'm actually just going to copy this. If you didn't know, you can scroll up and highlight it. If you press enter, it'll bring it back down. So all I have to do then is change the 65, and then we're going to divide that by the sine of 81. So 9.18 when I round it to the nearest hundredth. So 9.18 miles from station B. Okay, again, please, please, please do not try to use the Pythagorean theorem. These are not right triangles. So law of sines for everything that is our angle, side, angle, 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 side, or our side, side, angle. Anytime you write side, side, angle, don't forget to check for the ambiguous case like we had in C.